Hey everybody, Jason Sherman. In today's episode of Zero to CEO, I'm going to talk to Ori Raphael. He's the CEO and co-founder of Upsolver. Welcome to the show, man.
Thank you. Glad to be here.
Cool. And we're going to talk about revolutionizing data management. And this term that I saw in your notes, lake houses, is kind of new to me. I'm more familiar with like AWS and like traditional warehouses. So let's just help the audience understand what is a lake house and how is it different from a traditional data warehouse?
Sounds good. So I think that the easiest way to imagine it, and maybe to an example, is if you're going to use a warehouse, Snowflake, Redshift, BigQuery, whatever you're going to take, you are pretty locked to that data warehouse format. So let's say you want to go to another warehouse, you need to take all your data, copying it into a new warehouse, and then you can start enjoying the other warehouse. That locking is also very painful in the age that AI is exploding, because some warehouses are great for BI, but then you want to use something else for AI. How do you do that? You need to start copying the data out. So you need to do a data migration just to enjoy some of the new good AI tools that are out there. So the fact that your data is locked is both bad from a commercial standpoint. You're paying a lot of premium from your warehouse, but also from the ability to choose best of breed.
And
That's the incentive.
And let's make sure the audience understands when you say copy the data, really it's a lot harder than that. You're exporting, a SQL database, you're exporting your code, you're then importing it and migrating it into a new database, new infrastructure. You have to connect new API endpoints. There's a lot actually going on there behind the scenes. So it's a lot harder to do that, I think, than just saying copy your code. So I just want to make sure that's clear. Now, why do you think lake houses are the next big thing in data management? What's wrong with using traditional warehouses?
So I think that the problem is what I stated before on the high cost and the ability to use additional tools. And kind of the concept of a lake house is let's take the data out of the warehouse, manage that data externally, use the warehouse more as a pure query engine. So you can basically use a single data copy in order to entertain multiple different tools. That's the big advantage. That brings cost advantages to it. So for example, one of the things that I hear a lot from my customers is that I'm doing ingestion and I need to have a warehouse cluster up.
Well, let's talk about that. Exactly what is ingestion for people who don't know, because my audience might not be as technical as you'd like.
Yes. So let's say that I'm bringing data from Kafka. I'm doing a stream. I want to write it into the warehouse. The process of putting data inside the warehouse is called ingestion. Now, once I'm doing ingestion, I need to actually talk to the warehouse for the warehouse to accept the data and store it in its local proprietary managed storage. So you have to pay for the warehouse cluster all the time. Warehouse cluster is very expensive. You're just doing a simple operation, just wanting to copy the data in. If you're going to,
you keep saying very expensive. What are we talking about in terms of expenses, in like a differentiation of like the warehouse model versus the lake house model? You keep saying very expensive. What do you mean? Let's say you're a startup and you have 100,000 users and they're posting stuff on their profiles and on a feed and videos and things like that.
Yeah, the range is quite high. You would have those who pay thousands of dollars per year, and you'll have those who are going to pay tens of millions per year. And it really depends on your volume of data and number of users. But here, there's a good example of a cost that just goes away. So for example, when I do ingestion, I need to pay for the ETL, that's bringing the data from my source into the database. And then I need to pay for the database to accept the data. Those are two different costs. In the lakehouse model, where I basically just write the data and the warehouse, any warehouse can query it, I don't need to pay for the warehouse in order to do ingestion. I only need to pay for the warehouse in order to do queries. So that's a line item that just goes away. And it depends on which company you are and how much that line item is big, but it can be very big. ETL can be more than 50% of the cost of your warehouse. But it doesn't just stop with the ETL. Like most of the companies that I know, they're putting their data in a lake. That's where they park it first, let's say. And from there, they're kind of fanning out. Let's say I'm putting some of the data in the warehouse, some of the data in another database, like some of the data goes to applications. Like I'm starting to spread that out. But what if that lake copy that I already have can be queryable? that I don't need to copy that from the lake into the warehouse. So I'm actually saving one data copy of all my raw data. So I'm both saving the cost of the warehouse while doing ingestion, and I'm saving the cost of another copy.
I guess I'm still trying to understand like the difference between them, because it sounds like you're still storing the data, you're still querying the data. How is that different from a traditional, like let's say for example, we're storing daily videos, daily text messages, daily photos, and other information onto a DigitalOcean instance, okay, which is hosted by AWS. And when we search for those pieces of data, it's just going to the database and searching for those buckets and those items, those media. How is that different from hosting it on the? Is it being hosted on Lakehouse and we're still querying? I'm confused as to the difference between why that's different. I guess that's the differentiator I'm trying to find out. Because I'm sure people are going to ask me, so I would rather you answer.
Yeah. The differentiator is more on moving the data as opposed to querying the data. You're still going to pay for querying the data, regardless of what you're going to do.
Okay, so the querying doesn't change. Okay.
The querying doesn't change. Eventually, you still need to query the data. By the way, you could use the same tool. Like if I used to work with Snowflake, and now I'm going to work with Snowflake on a Lakehouse open format like Iceberg, then I'm still going to pay for queries. But the question is, how much are you going to pay to put the data in, and perhaps also to move the data into, usually data in a warehouse has multiple layers. So move data between all the layers. How much am I actually going to pay for that? Today, I'm going to pay the cost of a warehouse cluster that's basically more expensive than the cost of just moving the data around. Generally speaking, that will be more expensive because the warehouse is closer to the business user. It's a premium product. If I need to keep that warehouse up and run queries, that's going to be more expensive than just write files into S3. That's going to be a much cheaper process. The idea of a Lakehouse is you separate the writes from the reads. You write once and you read with whatever reader that you want, whenever you want. But that read part still is going to happen.
So what's the main expense that you're removing? Is it the storing of the data, reading, writing, storing? Is that are you removing that somehow?
I'm removing one data copy, because instead of storing the data in the lake and then again in the warehouse, I can use the copy in the lake in order to allow queries from the warehouse. So I'm basically removing one copy of the data. The staging area, which is the lake, can also be the query area. That's cost number one. Cost number two is when I write the data, I can just write files into S3. I don't need to spin up a warehouse cluster to actually accept the data. I can just write into S3. So that's a second cost that goes away.
So this is really something for like a CTO of a company really needs to understand the ins and outs of this. And there are probably going to be some challenges for an existing business to switch over to a Lakehouse. What are some of those challenges that you have seen companies face when they tried to switch over?
So this is actually one of the big advantages, and I think that migration is not that difficult. So, and that's of course compared to the alternative. Let's say that you have a warehouse A and you want to migrate it to warehouse B. The pain is that you're going to need to rewrite all your queries to fit the SQL of the new warehouse, and you need to copy all your data. Here, you can still use the same warehouse for queries. You don't need to rewrite all of your SQLs. All you need to do is, let's say I'm going to start with table A. That's the table that I'm writing. Instead of writing it in a proprietary warehouse format, I'm going to write it using open formats. I'm going to use Iceberg as the table format and Apache Parquet as the storage format. All the queries against that table will continue to work exactly as it was the proprietary format. You're just taking the beginning. You take the starting piece. Now, this would be a migration. So this is a case of migration. It's 1,000 times easier than migrating a full warehouse because you don't need to rewrite your query layer. In addition to that you don't need to do all of that part, I think that what's going to happen is that if you have a new use case, that new use case is going to be born in the Lakehouse. Companies are going to start gaining confidence around Lakehouse by starting with new use cases without any migration. Once they see that works well and they're happy with it, and that's already happening, then what they're going to do, they're going to start migrating all their use cases in order to reduce cost for those use cases as well.
Well, it's not just cost too. I mean, I read somewhere you wrote that you're able to handle 5 million events per second, which is what Upsolver has been able to do it by reducing cost, but also speed. I mean, speed is a big factor when you're running a startup. You need people to be able to access your data as quickly as possible. So how are you able to do that? How is it capable of doing that?
Sure, I'm happy to explain. I think that everything we talked about so far wasn't related to Upsolver. This is just why you should choose a lakehouse. This is why a lakehouse is going to be much better for you. The question is now, how are you going to build and manage that lakehouse? So Upsolver is a system that basically combines the concept of ETL, writing data into the warehouse lakehouse, and also managing the data. So today, when you write into a database, the database does a lot of things to make sure your queries are going to run fast. They optimize the file system, file sizes, compression, like all of that work. Now that you start managing your data outside the warehouse, you, Mr. Customer, you are responsible to do that. So we are a company that basically combines and integrated those two functionalities into a single product. Now, that's kind of the main advantage. It seems that a vertically integrated product basically simplifies the process of building a lakehouse. Just click, hey, I want to bring data from here, and it's ready in the lakehouse, and it's going to perform well, and all of that is going to work. That's the Upsolver value proposition. Why are we doing it fast? We were born into the cloud. So we were able to use the cloud benefits in a very similar way to how Snowflake did it. So Snowflake idea, Snowflake, biggest data, one of the most popular data warehouses out there. Yeah. The idea was the data is kept on S3, and then you can have multiple clusters that are going to read that data from S3. And each of those clusters are not sharing anything. And if the cluster goes away, you just shut it down, you can just spin it up. It doesn't have a local state. The state is the data, and the data is on S3. We basically apply the same concept, but for processing. Upsolver has multiple clusters, and each cluster has multiple instances, and all of those are not sharing data except on S3. So tomorrow, if my customer has double the data, I can just spin up double the servers, address that workload, that peak, and then go back into the normal state. So the fact we are cloud native with a shared nothing architecture except data on S3 is the reason we can basically scale as long as AWS has storage of instances.
Makes a lot of sense. So you must know a lot about the future of data storage and analysis. What are your thoughts on where we're headed, just so people can hear?
Well, you can say that I'm a little biased, but to me, the change that's happening in Lakehouse is maybe the most exciting change we've seen in maybe decades. So the idea that the customer can, basically a database, the data warehouse is being broken apart. It used to be like this big monolith that did data management and queries, and you had to choose one and stay with it forever. That concept is going away. You can you are the owner of your data, and others can give you values. That for an AI use case, I'm going to choose A. For a BI use case, I'm going to choose B. Maybe for the same BI use case, I'm going to combine 3 different query engines because each one is giving me better price performance for a specific query that I'm running as part of the same use. You can basically, the fact that the database is being broken apart is something that people have been talking about since the beginning of Hadoop. That's the idea of Hadoop. Let's build a warehouse with lake economics. And, it was always like really hard to do. People called it data swamps because it was so hard to do. But one of the main reasons that happened is that there wasn't a standard of how to store data that all the warehouses could align to. The rise of Apache Iceberg, the open table format, basically gives you that standard. And once you support that standard and stores the data in the lake, according to that standard, all the warehouses are going to be able to query your data. So that standard is just emerging, like invented a few years ago, catching fire right now. So that's basically, I think that right now there is a race between everyone, all the warehouses, the data integration companies, to who is going to support the open lakehouse in the best way. I think that's very, very exciting. So open storage to me is the most exciting thing about storage right now. Of course, we can talk about the AI is a pretty exciting movement as well. But you
Of
asked me
course.
about storage. So I think with storage, I'm super excited about open storage.
Perfect. And where can people get more information about what you guys do?
They can just go to upsolver.com. You can learn more about the product, the videos, learn about use cases, see what customers are doing, and also on social. You can find us on LinkedIn, on Twitter, on our Slack community, and we are happy to answer questions there.
Nice, Ori. Thanks a lot. And guys, check out upsolver.com. Hope you guys enjoyed the episode, and we'll talk to you the next one.